Here's some quick soldering advice. The first thing is get a soldering iron that's decent. Our entire objective is to get as much heat as possible right here when we want it. So things like, so basically heat moves just through this thing. When it gets to the tip, it will push heat into the next part, ideally, but if it can't keep up because it's not powerful enough or it's just kind of weedy with it, you're gonna run into some issues. Whole objective is keep everything fluid, keep everything wet. Best way to do that is with a decent one. This is a STM32 from Amazon. They're super cheap. I think it was like 60 bucks, and it's great. I actually powered off of a battery pack, so that's really nice. I can just literally put the battery pack in my pocket and walk around and do whatever I need to do with soldering. So big things you want to know about this. The whole objective is to keep everything liquid. So you can use lead solder. This is lead-free solder. I like that more because this you should really be careful with because, you know, lead. You don't touch your mouth. Other things to keep in mind. This gets a lot of oxidation on it. Oxidation will definitely hurt you. We want to clean off the tip to get as much of the excess off of there, excess solder, and keep it clean. Everything you want to be constantly working with a liquid. So that means you want liquid here, you want liquid down here on the piece. That all of that goes together to make everything fluid and work quickly. You should never have to like touch this here for 10 seconds or 20 seconds to heat it up. There's a chance that you're just like pushing heat out through the rest of the part slowly and burning out other components. So if I'm putting low heat here, it may start pushing into the next components, which we don't want. We want to hit it hard with some heat, enough heat, not too much, so you get used to that. I have mine set to 310 Celsius. It's kind of preference on how much heat, how long you want to leave it on something. Here's the next thing you need. Decent flux. Well, just flux. Flux will basically remove the layer of oxidation on top of an item, on top of a metal, and let the liquid flow together. So here's an example. I'll just take some of this flux and some solder and touch it here, and then just add a whole bunch. Now what's going to happen as soon as I let off of this, I'm going to add a whole bunch, way too much. Let off, it's going to change from silver to gray. And when it switches to gray, that's when it's oxidized. So if I were to try to touch this again with just a dry tip, watch what happens. It's going to work very slowly to actually like add heat to it. Imagine you don't get a good like contact point between these because it's going through an oxidized layer and it's very slow. So I'm going to let that cool. It barely made a dent in it. So what I'm going to do instead is add some flux and do it again. You'll see how much faster it goes. And I'll add a little bit of liquid to this so it all flows together nicely. This will help a ton. Okay, you can actually hear it sizzle, and the whole thing turns into a liquid blob, and it's hardened again. So it is difficult to work with this. I may need more heat, but that's how you do it generally. All right, same thing with these parts. Keep in mind this part has a top, bottom, and a middle through piece. That will take it. You can burn all these off. You can burn the rings off, you can burn pieces off, you can make it so the connection through doesn't work anymore. So it's all about just being careful with how much heat you're applying.